Okay, in the previous class we have gone through different type of instructions available to 8086. In the previous class we have gone through this data transfer related instructions, and then after that we have seen arithmetical type of instructions basically. Next we will see how we can have the logical related instructions basically. So this logical related instructions that we are in AND gate and OR gate we have seen. Next we have XOR, and we have also seen this XOR. Next we will see the test. So your test is an instruction, logical instruction. Basically this test will be similar to the AND instructions. Okay. The only difference is in test two inputs are given, so it will be performing this AND operation. So AND of these two will be performed and will perform, but after performing the AND, the result will not be stored here. Here what will be there in test, basically it will be performing the AND only, but the only difference is it will only affecting the flag. So flag bits will only be affected by this test. No operand, no operand will be changed. So no operand data will be changed. It will be performing the AND operation with these two, but after performing this AND, there will be the result will not be stored anywhere. The only changes will be taking place is it will be modifying the flags. Okay, so this is your test. So test will be of either operand is given in terms of register 1 or register 2, or it will be with respect to register 2 and a memory with register 1. And if we are providing a memory data, it will be with respect to a register or with respect to a memory. Okay, this is how we will be performing the AND operation, and it will be modifying the flags. And one more type is data. So data, a comma data is there, that means with respect to data, the accumulator will be used. If it is 8 bit, AL will be accumulator. If it is 16 bit, AX will be the accumulator. Next one is shift instructions. So in shift instructions, basically we are going to shift the data. So here shift with register. So one of the example is SHR means shift right. It is shift we are shifting right to the data of register. So whatever data of register is there, and this one indicate one time. That means one time we will be shifting. Similar to this second part, SHR, that means shift right to this register value, whatever content is there. How many times we will be shifting, that is stored by the CL value. So the CL basically indicate the count, like how many times shifting will be performed. That is stored by the CL register. Okay, and similar to this register, if it is a memory location, with respect to that similar instruction, similar operation will be performed. The difference is here, if we are going to shift, it is shift right. That means we are shifting from left to right. So here this is how the shifting is taking place. So this LSD is there. What is there? LSD means least significant digit. This least significant digit will be moving to carry flag, but this most significant digit will be replaced by a 0. If we are shifting means we will be adding 0 to the MSD side. Okay, if we are shifting to the right direction. Okay, so this is indicated by this symbol. Okay, similarly this is for right shift. Similarly, if we want to shift to the left, this is SHL mnemonics will be used, or instead of SHL, We can have SAL also. So these two mnemonics are used for the uh, hold, sorry, shift related instructions. We are shifting, either we could use SHL or SAL. Okay. So if it is with respect to register, this is SHL register comma 1. That means we need to shift left shift this register content with 1. So one time we should be shifting left. So here if it is written this register comma CL, that means we need to shift CL times. So whatever content of CL is there, we need to shift the content of register to the CL times. So similarly in this case, like we are shifting left, that means from the right we are shifting to the left. So one thing, like once we are shifting left, so whatever MST is there, this will be coming to the carry flag, and this LST will be obtained with 0. So whenever we are shifting, 0 will be included, like here will be adding a 0. It is left shift, so right part, so the most right will be added with a 0 content. So this is indicated by this. Okay. Similar is with respect to memory content. The next one is rotate. So there RCR is there. So RCR means rotate right with the carry. Okay. So this is rotate right with the carry. Okay. So we are going to rotate with the carry. So it's like RCR register comma 1. That means similar to a shift. It is like we are rotating with the carry. This one indicates like we should be rotating one time. Okay. So one time rotation. So if in this case RCR register comma CL, that means we need to rotate CL times. So CL is 5. Suppose CL content is 05 H. That means we should be rotating 5 times, okay, to the right. Rotate right 5 times. And this C is there, that means we need to rotate with the carry. So the example is given like, so we are rotating the right side. So we are rotating right side, and in this we can get like we are rotating with the carry. That means the rotation will be included with the carry flag bit. So LSD bit will be going to the carry flag. Okay. And this carry flag now will come to the MSD side, and this MSD should be rotating to the right side. Okay. This is how the right side rotation will be done. Okay. Similar is with respect to the memory content is there. This is how the rotation should be there with including the carry flag. So what is the difference between shift and rotate? So one thing, like in shift we will be adding 0, like adding a 0, but in rotate no 0 is added basically. So here it is in shift we are adding the 0, because here we can see when it is left shift to the right side we are including the 0, and this carry flag whatever content is there, this is not going to repeat to the least significant digit. But in case of rotate means we are having a closed loop type of structure. If we are rotating right, it is going right, then carry flag will come up to the MSD side, and this is like a closed loop is formed. So this is rotate. But in shift it is in one direction. In shift it is in one direction only. And this one is like loop type. It is like a loop type is there. This is in one direction only, either right or left. But it is a loop. It is in the right side, but it is this data flag data carry flag data is going back to the MSD side, and this is again keep on rotating with respect to the CL value. This is how the rotate works. Okay. So the next is ROL is there. That means rotate left. we are going to rotate, but here C is not included. So in the instruction C is not there, that means we should be performing the rotation without carry. Rotate without carry if C is not included. So here, like, we need to rotate left. We are rotating the left to the content of register by one time. Similarly, rotate register content to the left by CL times. So in here, like, we are rotating to the left side, but this MSD bit data will be coming to the carry flag, and this MSD data will again be rotated back to the LSD side. So this is how the rotation is going to take place. Okay, so the rotation is going to take place, but in the loop, only the data available to the register and memory that will be rotated, but the carry flag data will not be moving anywhere, but it will be affected by this MSD bit that has been included into this description. Similar is with the next one. Next is like string manipulation instructions. So here string manipulation instruction. So here string basically this string basically indicate like sequence of byte or word. That means if memory is there, there are different 1 byte spaces are there. Suppose this is 1, 2, 3, 4, 5, 6. This is one of the segments, suppose, and we want to move a data from one segment to another segment, but starting from 1 2 3 4 5 6 up to this, all this data we need to copy to another segment in the same order. So here we need to copy 1 2 3 4 5 6 of from here to here. So so this group of data is considered as string. So string manipulation instruction means if we are going to performs a particular operation on all the type of data. So this all data we are going to perform the same instruction on all data, then that group of data will be considered as string. And whatever operation we will be performing, like we want to move this data to some other location in the same manner, then that is like string related operation. So we will be performing some string related operations that can only be done in 8086. It does not support in 8085. In 8085, no string related instructions were there. So here basically there are some operations with respect to string. So one is like we will be moving the string, or we will be comparing, or we can have scan or load or store. They are the different operations performed by a string. And one is like a repeat. So this repeat is, if this repeat is written, rep is written, this will be working as a prefix. This means whatever next is there to repeat, that means that instruction will be executed again and again. Okay, so it is basically used to repeat execution of string instructions. Okay, so in the string instruction mnemonics, there are some symbols that are used like S, SP, and SW. So if S is written, that means it is any string related operation is there. If it is SB is written, that means it is a string related operation, but that string operation will be performing byte by byte. So that is a string operation will be performed by byte and byte data. Okay. If it is written as W, that means we are going to perform a string related operation, but that operation will be performed word by word. Word by word means there will be 2 byte of data on which we will be performing the string operation one time. Okay. Similarly, in this string related operations, the offset address or the effective address is basically given by the SI and DI that we have already seen. Here SI will be indicating the source operand and DI will be indicating the destination operand. Okay, so in this string related operations, SI and DI will be giving you out the two operand options. One will be source operand and the other is destination operand. Okay, so depending on the flag, here direction flag is used to operate the string operations we have seen in the flag status also. Like what does this direction flags indicate is like it is used basically for string related operations. So this operation, string related operation, to be performed in incremented address order. So if this is the memory address, here it is 00000, and here it is f f f f f. Okay, so if we are going to perform and string operation such that the memory address is in increasing order, okay, then this will be called like auto incremented string operation, or this will be performed only when the df is equals to 0. If direction flag is equals to 0, this type of operation will be performed, like the source and destination in, offset addresses will be increasing. Okay, similarly, if direction flag value is 1, that means if direction flag value is 1, then the operations will be performed such that the address will be decreasing. That means from higher to lower address it will be moving. So the destination and in source index value will be either decremented by 1 if it is byte related operation, or it will be decremented by 2 if word related operation is there. Similarly, in case of df is equals to 0, these two will be incremented by 1 if byte related operation is there, by it will be incremented by 2 if word related operations are there. So these are the different string manipulation instructions are there. So the first one is REP. So REP basically have different variations, like if it is REP Z is there, that means repeat. Okay, we need to repeat such that if it is not, if it is 0, if it is 0 till now we will be repeating. Okay, so it will be or repeat E. Repeat E means we will be checking the flag basically. So either it is 0 or not. Okay, repeat. So here this will be condition, will be giving the condition like if cx is not equals to 0 and 0 flag is 1, then this instruction will be keep on repeating, and after repeating it will be decrementing the cx value by 1 and it will be putting to the cx. That means cx will be working as by default the count. So count will be working, cx will be working as a count in repeat instructions. Okay, okay, so this is like it will be repeating, so till 0 flag is 0 basically. Okay, so it will be repeating. So cx will be, if cx is not equals to 0, that means 0 flag will be 1. In these conditions it will be repeating. If cx is equals to 0, that means 0 flag will become 0. So in that case this will be stopped. Similarly, it is like repeat nz or repeat ne. So here it will be again keep on repeating such that if 0 flag is equals to 0. So if 0 flag is equals to 1, then this will be stopped, otherwise it will keep on repeating. Okay, next is move sp. So move means we need to move the data. So move, similar to the move previously we have seen. Move, after that it is written like s, so this is like string. So move string data. B means byte, so we need to move string data byte by byte. Okay, so we need to move string data byte by byte. Okay, so here we will be moving the data from the, so all the data are stored in basically the data segment. So all the data that we will be performing the instructions, some operations that will be stored in data segment. And one is also a data segment, similar to data segment. To store the data we use extra segment. Okay, So if we are moving, so in here basically we will be moving like from data segment to extra segment. We are moving some data, some content are moved from data segment to extra segment. Okay, so basically is moved by MOVSP. So this addresses will be given like so. This uh, memory address that will be for the data segment type of means for this is basically for source data. The address memory address will be given like data segment multiplied by 16 decimal plus SI, that is offset address in case of source data, and this is like MAE, that is the destination. Okay, so destination address will be given by like extra segment multiplied by 16 plus DI, destination index. So we are moving the data from source, to the destination. Okay, and this movement will be like either we are moving from 0 to higher or from higher address to lower address. That will be depending on the DF value. So direction flag is 0. If it is 0, that means we will be moving from uh, lower address to higher address. Like we will be copying this data first to here, then next data having higher address, then next data having higher address, next data having higher address, that will be moving. That is called if df is equals to 0. Similarly, if df is equals to 1, in that case, if df is equals to 1, that means first movement of data will be taking place from the higher address. We will be moving from higher address to here, then we will be moving to lower address, and then lower address, and then lower address. This is the case when df is equals to 1. Okay, same is like the movement of one byte of data. Similarly, we can have the movement of data in case of like the movement is in case of a word. If a word movement is there, that means the movement will be considered when MA. This MA is moved to MAE, and one more address higher value of MA plus 1 will be moving to MA MAE plus 1. This is how the one byte of data movement will be taking place. So here in this case, the increment or decrement of source and destination will be taking place in terms of two steps. 2 plus or 2 minus will be taking place because it is a word related operation is there. Similarly, this is uh, copy, sorry, it is a compare. So we are going to compare, this is compare, this is string. So we are going to compare string data, and this is byte by byte. If we are going to compare string data byte by byte, that will be compared like CMP SP. So here we are comparing, means we are going to compare the data available on data segment and data available on extra segment, and its addresses. In extra segment, the offset address, this offset address will be given by destination index, and here in case of data segment, this offset address will be given by source index. Okay, so this is how we will be calculating the memory addresses of source and destination. Once we have done this, compare means we will be subtracting. So here source data minus destination data is being done. After that, how it is going to affect the flag, based on that we can give the result, like how we can compare which one is larger and which one is smaller or equal. Okay, based on that modification of the flag, we can get the comparison result. This is in case of word, simple byte related data. Similarly, for word related data, we can have the similar instruction, but the only difference will be the same, the address reduction. If it is one byte instruction, one byte will be one address will be incremented or decremented. In case of the byte instruction, plus minus 2 address will be taking place. This is scan B, scan S, scan SB. So like we are going to have scanning. We are going to scan string related data byte by byte. So scanning here means we are going to scan with the accumulator content. We are going to scan with accumulator content. If we are going to scan with accumulator content, that will be considered as scan. That means scanning here basically done as comparing. So in comparing and comparison and scan, what is the difference is like in comparison we have destination and source. Source data and destination data is given in comparison. But in case of scan, only the source data as in the destination data is given. Okay, so here in scan, destination data is given plus accumulator data is given. Okay, so source here, this will be the source. So source will always be and accumulator. So that is the source. This accumulator content will be compared with the destination, that is considered as scan. Okay, load here, LOD, like load, we are going to load string data byte by byte. We are going to load. So loading means we will be loading the source data is moved to accumulator basically. So this is like moving. So source means we are from data segment, the data is copied to accumulator. So this is accumulator. Okay, if it is accumulator, this is how the movement is taking place from data segment to accumulator. It is called as load. Okay, so similarly loading will be like we are moving from MA to AM, and loading will be done with respect to DFL. Similarly for the uh, word related data, we can have the same. Decremented will be with respect to plus minus 2, and the same, the first location will be stored in the lower one, the higher will be stored in higher one. So this is how the loading will be taking place. Next one is storing. So here in storing, what we are doing is uh, we are storing into the stack segment. We are loading means we are considering we have loaded to the accumulator. Now we are storing means we are storing the data to the extra segment. So extra segment data, so data from the accumulator will be stored to the extra segment location, memory location. That will be considered as this process will be considered as storing. String storing. Okay, similar method is there. So we are just having the storing. So we are storing the accumulator data to the destination address. Similarly here, AX value, lower value will be included here and higher value will be included here. Okay, and reduction will be taking plus minus 1 or plus minus 2 based on byte and word related operation. This is processor controlled instructions. So processor controlled instructions does not require. So this uh, no operand is required basically. So here no operand is required. So if no operand is required, that means whatever instructions is written, it is complete in itself, like STC. So it is STC means set carry flag. So it is set carry flag. CLC, that means clear carry flag. CMC, that means complement carry flag, and so on. These are self-defined instructions. Basically, they are like explicit type of addressing modes are there. This processor control instructions. Okay. Next one is control transfer instruction. Control transfer means we are going to give the control of executing the instruction from one location to another location. That is considered as control transfer instruction. So here transfer the control to a specific destination or target will be considered as the giving control related operation. It will not affect the flag. So here data related operations are not performed by this control transfer instructions, so it will not be affecting the flags. Okay, because no data transfer or arithmetic operations are performed. So there are no arithmetic or data transfer operations are performed by using this control transfer instructions. So it will not be affecting the flag. So basically, it is of different types, like two types basically. So one is unconditional. Unconditional means there is no condition. So one is call. So call with register or memory or some address is there. So if this is after call some address is given, then it will directly going to that address without any condition. This is called call subroutine. So if it is like some instruction is written and here call with a 16-bit address is given, then what it will do is, that means after that some instruction is written, previous to that also some instruction is written. So if this is written, that means it will after call it will go for this 16-bit address location. Whatever program is there, it will be executing. After that there will be a return. So this return will coming back to this location from where the next instructions will be performing. This is how the call is used. So this return will basically give you like from where the call has started. So whatever next instruction is there after executing the call subroutine, whatever is program are there, after executing this, a return will be there at the end, and that will get back the processor to the next instruction of this call. After call, whatever the next instruction is there, that will be executed. Jump. Here jump is there with the location, direct location is there given, and there is no condition given, that means it is an unconditional jump is there. Okay, so these are like unconditional transfers are there, there is no specific condition is given. Next is some conditional. So here in conditional type of transfers, it will be basically checking the flags. What is the condition? Based on the condition, it will be giving the transfer or not. Okay, so in this conditional, it is considered like signed and unsigned. So here in conditional, basically if conditions are true, the program control is transferred to the new memory location in the same segment by modifying the content of the IP. So here, in case of conditional branch instructions, it will go for checking, and once this check after checking, if the condition is true, it will be switching to the next memory location by changing the value of instruction pointer IP register. There are different control transfer instructions with signed or conditional in branch instruction, and some unsigned conditional branch instructions are there. So like JE, this 8-bit data is there. That means jump if equal. So if this data is equal to equal, then it will be going to jump. Otherwise, it will not be jumping. Okay. Similarly, if jump if not equal, whatever data is there, if the data is not equal to accumulated data, that will be not equal, then it will be going to jump. Similarly, there are different conditions you can see. Okay, the next one is control transfer instruction. Here the conditions are with respect to the flag status. So whatever flag status are there, based on that the conditions are there, like JC with the display. So jump if carry, jump if carry to this location. Okay, so jump when no carry. jump if query, jump when no query, jump when parity, jump no. Okay, so this is how based on the condition flag status the jump instruction will be performing. So that up to now, up to this point, the basic instruction sets of 8086 have been discussed. Uh, the next point we will be discussing is like difference between 8086 and 8088. So here comparison is done. So the similarity is like in 8088 and 8086, execution unit and instruction sets are basically common, but the only difference is bus interface unit. So bus interface unit has difference between 8086 and 8088. Basically, the difference is like in 8086, bus interface unit has 6 byte of instruction queue, but in case of 8088, it is of 4 byte of instruction queue, basically. Okay, and also 16-bit data lines obtained by demultiplexing 80 to 8515. So here 16-bit data lines are there, that is multiplexed with these pins, but here 8-bit data lines are there, and it is multiplexed with this. Okay, so here 20-bit address lines is there, here 8-bit address lines are there. So if 20-bit address lines are there, that means total addressable memory location will be 10 to the power 20. That means whatever 10 to the power 20 is there, that is coming out to be around 64k. Okay, so here in case of 8-bit addresses, it will be maximum 10 to the power 8. Okay, that much of you can say uh, that much of memory locations will be addressable. You can address only this much of memory location, but in case of 806, it can access this much of memory location. Basically, it is of like 1 MB. It will be coming out to be 1 MB. So here, this memory 1 MB is basically divided into two banks. One is 512 KB, another one is 512 KB. But in case of 808, a single memory bank is there, that is of 10 for 8 location. And this 6 byte instruction queue and 4 byte instruction queue, it has clock speed of 5, 8, and 10 megahertz. It has 5 and 8 megahertz only. In case of 806, pin number 28 gives the signal like M oblique input output bar. So here this is in case of minimum mode. Here if it is this pin is 1, that means it is operating for memory related operations. If it is 0, that means it is going for input output related operations, this processor. But in case of 808, 28 number pin is having configuration the signal value, that is input output oblique memory bar. So this is in minimum mode. So in this case, here if it is 1, that means it is performing input output related operations. If it is 0, it is performing the memory related operations. So this is how these two are different. Okay, and also in 8086, the higher byte of addresses is basically accessed by BHE pin, BHE bar signal, but there is no such signal is available in 8088 basically. Okay, this is the difference between 80186 and 80286. Mm, we will be comparing these two processors. So in 80186, it is of 16-bit data lines. Here also a 16-bit data lines is there, but in case of 80186, 20-bit address lines are there, 24-bit address lines are there. This 80186 basically a modified version of 8086, and this 80286 is basically the modified version of this 80186 modified version. Here multiplexed address and data lines are there. Here address and data lines are not multiplexed. So if it is not multiplexed, that means address and data lines basically consist of different pins, individual pins. That means it is having this this processor is having higher number of pins. Okay, so here it is multiplexed. If it is multiplexed, it will be using less number of pins. Okay, it has addressable memory space to the power 20, that is 1 MB. In case of here, it is 20 address lines, 24 bit address lines are there, and 24, that means 16 MB of memory it can address. Here, the 20 bit physical address is basically given by 16-bit segment register and 16-bit offset address similar to 8086. But in case of here, 80286 is upward compatible with 8086, and that means whatever programs are written in 8086 can run onto this 80286 also. On 80186, on-chip timer, DMA controller, and clock generator and interrupt controllers are available on this 80186 only. But on 8286, no on-chip clock generator is there. So to have clock generator, external 82284 chip is required as an external clock in 80286. It can have this 8086 have operation frequency of 8 MHz or 6 MHz. But in case of 80286, it is having 4 MHz, 6 MHz, and 8 MHz. In case of 8 MHz of 80186, it is giving out two times higher throughput than 8086. If 80286 is operating at 8 MHz, then it has the 6 times higher throughput than 5 MHz working 8086 processor. In 80186, it has all registers available at 8086, and also it is code object code compatible with 8086. So the codes of 8016 is compatible with 8086. 80286 is basically work in two different modes. So this one mode is like real mode. If it is working in real mode, that means it will be operating such that it is compatible with 8086. This is called real mode. If 80286 is operating in protected mode, that means it is working such that it has some enhanced features. Okay, in that enhanced feature, one of the enhanced feature is like it has on-chip memory protection capabilities. It has on-chip memory protection capabilities. Okay, and also this 80186 has processor. It is considered to be a processor that is having peripherals. So the peripherals are available here, like timer controller, timer system controller, DMA controller, clock generator, interrupt controller. They are available on 80186 itself. And also it has 10 new instructions with respect to 8086. With respect to 8086, it has 10 more instructions. Okay. Basically, it is used for embedded related applications. But this 8286 is designed for working as a multi-user or a multitasking system. For multitasking and multi-user systems, 80286 is basically used. So, okay, so till now we have seen the basic instruction sets of 8086 and the difference between 8086 and 8088 and 80186 and 80286. And in the next class, basically, we will go with the basic programmings. The basic programmings of 8086 microprocessor basically. So some of the basic programmings we will be seeing. So till now, if anyone is having any confusion or question, you can just comment down below. And mm, to get my videos, kindly subscribe to my channel, and so that you can get my videos notification with a timely manner. Also, if the video will be uploaded, that will be with respect to your timing, the class timing, whatever the class timing is there. With respect to that, the video will be uploaded, and you can just access the videos at your scheduled time. Okay, and the same link I will be providing to the WhatsApp group also. So from there also you can access the same video on your scheduled time. Okay, so thank you, and whatever queries are there, you can just comment in the comment section. Okay, thank you.